Okay, hello. Today we're going to talk about in our lesson 5.7, which really is what's called the fundamental theorem of algebra. And the fundamental theorem of algebra just really alludes to how many zeros a polynomial has. Now we need to be careful because every zero zeros are going to lead us to x-intercepts and also factors. So we call them roots or solutions, most importantly zeros, which again remind us are x-intercepts and or factors. And then there are some special types of zeros that we need to be aware of something called conjugates with. So we're going to talk about complex imaginary numbers when we square and negative, and also irrational conjugates, which the fundamental theorem of algebra polynomials, and it is always equal to the degree of the polynomial. So if we look at our two examples here, when we talk about the degree, we don't mean all of the degrees 4 and 2 and actually 0 for that one. We only care about that highest degree. So the degree of this polynomial is 4, which tells us that there are 4 zeros to this polynomial. Okay, now with that in mind, that does not mean that there are 4 x-intercepts also. It means there are 4 zeros. Some of those could be complex solutions, at which point they wouldn't actually be an x-intercept. If they were rational or irrational, then they would be an x-intercept. Okay, a little trick on this one down here, we're looking at 2, but since this isn't in standard form, we may miss that 3, and here we're going to have 3 zeros because that's actually the degree, the highest exponent that we have. Okay, now, when we talk about complex conjugates, what that means, we're going to have a complex number like a plus bi. So we've seen some of those in the past, like let's say we had a complex number of 5 plus 7i. Then it always has a conjugate pair, a minus bi. So if 5 plus 7i is a complex number, then its conjugate pair would be 5 minus 7i. So you notice the real part, a, those 5s, I didn't change their sign. I only changed the sign of the complex piece, the imaginary piece, b and negative bi, so 7 and 7i. If a complex number is a 0, so this is the important piece for our fundamental theorem of algebra, then its conjugate also has to be 0. So if 5 plus 7i was a 0 for a polynomial, then 5 minus 7i would have to be a 0 as well. An example of that might look, if I give you f of x equals x cubed plus 5x squared plus 4x plus 20. Now I know there has to be 3 zeros because that degree is 3 and that's the highest degree. And let's say I found that one of those zeros was negative 5, and I did that through synthetic division or that rational roots theorem that we were talking about in the last section. Then I could go a step further, because if I did synthetic division with this, I would create a quadratic. Remember, that means an x squared term, at which point we could do the quadratic formula, and in this case we'd need to do that because we wouldn't be able to factor, because the next zero that we'd find would be 2i from that quadratic formula. Now if that's a 0, then that also means that its conjugate pair, which would be negative 2i, also has to be 0, and now we have 1, 2, 3 zeros, and we'd be done looking for them. Okay, conversely, I could also have given you these 3 zeros and told you to write these or this polynomial. So that would mean that since x minus 5 is a 0, x plus 5 is a factor. Since 2i is a 0, x minus 2i is a factor. And since negative 2i is a 0, x plus 2i is a factor. Okay, so we would have our 3 factors. We can multiply those together by multiplying polynomials, and we'd end up with that polynomial. Okay, in the same idea, an irrational conjugate, so a plus bi. So if I use those same numbers, I could say 5 plus the square root of 7. Then it has a conjugate pair, a, that should actually be a minus the square root of bi. So its conjugate pair would be 5 minus the square root of 7. Okay, and if an irrational number is a 0, then that means also, same idea, its conjugate is also a 0. So if 5 plus square root of 7 was a 0, so would 5 minus square root of 7. Okay, similar example, x cubed minus 7x squared plus 11x plus 3. We could do, again, that rational roots theorem. We could find that 3 is a 0, do synthetic division, create an x squared term, and therefore we could use that, and if we plugged into our quadratic formula, we'd get that 2 plus square root of 5 is a 0, which means to minus the square root of 5 is 0. And we could do the same concept. We could write those as factors. So this would factor to x minus 3, because that first one. I'd say x minus, and then I put in parentheses 2 plus square root of 5, and then the last one x minus, and then in parentheses 2 minus square root of 5. Okay, so if something is a 0, remember it's also a factor. Okay, and so that is it for this lesson. Biggest thing to remember is that fundamental theorem of algebra tells you how many zeros there are, which can lead us to x-intercepts and also to factors, and that some of those zeros, if they are imaginary or irrational, are always going to exist in conjugate pairs. All right, see you next time, guys.